Right, so in these next couple of examples, we're actually going to be diving full-fledged into this world of logical equivalencies. The idea here is I'm going to kind of remove myself from all those giant math expressions as well as some of these horribly convoluted English expressions and really just dive into the symbolic logic that's underlying a bunch of that stuff. So you can think about this as being the second stage in all these problems. The first one is take this giant expression, convert it to symbols. Now I have it all in symbols and I want to think about how can I massage these things or create new objects out of them. So what's going to happen here is I'm going to build up this giant war chest or this toolbox or however you want to think about it of a bunch of things that I already know. These are going to be the building blocks that I'm going to try to build up a whole bunch of known facts. So that's exactly what I've done below is I've just kind of sketched out a whole bunch of the stuff that we already know. Some of these things we're going to be showing, some of them we've used over and over again. And I'm starting off this list with the big and most important two, the idea that I'm going to have these De Morgan's laws and these classic conditional statements. The De Morgan's laws again give me this ability that I can go ahead and negate some of these and or expressions. What's going to happen is that that symbol in the middle is going to flip. If it was an or, it becomes an and vice versa. And both of those two statements are going to pick up these negations. So the idea is that if you negate P and Q, what's going to happen is I'm going to have not P or not Q. And that's exactly what that first one says. And you can do the exact same thing by switching those ands and ors around. Next, we're going to have the big conditional statements. Some of these we've used quite a bit already. The idea that we have our contrapositive. So if I have P implies Q, I know that this thing is logically equivalent to not Q implies not P. I can flip my hypothesis and conclusion as long as I pick up some of these negations. The third one on that list then is going to be this, how do I negate a conditional expression? The idea that the negation of P implies Q is simply going to be P and not Q. The giant, huge one that the negation of a conditional is not another conditional. And I'll kind of keep on saying that over and over and over again. The one that's actually sandwiched between those two things is going to be this somewhat slick fact that you may or may not have kind of picked up on as we've gone through this. The idea that you can take one of these conditional expressions, this P implies Q, and you can actually write this thing as an or. The idea that P implies Q is going to be not P or Q. So if you want to, you can really quickly sketch out a truth table for that one just to make sure that you do actually believe that. You'll probably end up having that one in a homework or something just to kind of double check your understanding of those things as well. So those are kind of the big first five that are going to become some of our most important tools as we go through this. Underneath that's going to be our biconditional statement, the idea that P implies Q and Q implies P is the exact same thing as P if and only if Q. The idea of this kind of double-headed arrow means that there's an arrow going from P to Q as well as an arrow going from Q back to P, and they're going to be separated by an and. After that's going to be the double negation, the idea that if I take my statement P, if I negate it and then negate it again, I'm right back to where I started. Underneath that's going to be our classic distributive laws, and these work just like your kind of distributive laws from algebra courses as well. The idea is that I can take this P or this giant expression and you can distribute that little or into those things. The idea is that it's kind of like a P with the or is going to pick up on that Q, which is why you have a P or Q, and then it's going to distribute into the R as well. So a P or R comes up at the end, and they're still going to be separated by whatever object was separating those two things originally. So we'll see some of those come into play a little bit more to kind of get some practice with how these distributive laws work. And then the very last ones are actually included in the text, and they're included in a bunch of text, but they're sometimes more complicated to remember, and we'll kind of show where they come from and kind of mention that maybe it's just easier to build those things up as you go rather than trying to remember these weird conditionals with conjunctions. They're sometimes more challenging to work with, but we'll see them kind of as we go. So the idea is that this is going to become our war chest or our toolbox, or like I said, however you want to think about it, your building blocks to create a whole bunch of new things. So what we're going to try to do is we're going to try to create, let's say, a new object. You could think about once you built this thing, you could also add this into your new toolbox. So that's what all of these problems are going to be about. They're all going to say, use some of these known logical equivalencies to actually try to prove something new. You could always go ahead and try to prove these things new with a truth table, but as you've seen, once you have more than 3 kind of statements involved, these truth tables have become very giant. If you only have 2 things, probably the truth table is actually a shorter way of showing these things, but it kind of helps us see what's going on. But once you start having 3 or 4 or 5 or 6 or however many statements, those truth tables are going to become enormous, and you really do want to go just into the algebraic manipulations of these things. So that's what these are all about, is just kind of practice working with the algebra of these logical equivalencies to kind of shed some light into what's going on. We've actually done a few of these kind of indirectly whenever we were doing those writing a negation of something and then I wrote a few equivalencies afterwards. You were using some of these known facts. I'd be like, hey, here's where we're using De Morgan's, or I'm using this double negation. That's all I'm doing here, except for we're going to try to be a little bit more formal while sketching out these things. So in this case, I want to look at showing this logical equivalence. This P or Q is going to be the same thing as not P implies Q. So like I said, the idea is that I'm going to try to add this new blue object to our known list. And what I'm going to do in this case is I'm going to start with one of these two sides and work towards the other side. In this case, I always like to work with whatever side has the conditional, convert that conditional into something else, and try to manipulate it from there. So that's the idea. So I'm going to have a solution in this case, which is going to start with not P implies Q. I'm going to try to rewrite this as something, and then my ultimate goal is that at the end of this kind of chain of equivalencies, this P or Q is going to pop up. The idea is that I want to take this thing, and I'm going to view this, in a sense, it looks like the expression A or A implies B. What I want to do is I want to look back at my table and say, what else can I write this A implies B as? In this case, you can see that simply P implies Q is going to be not P or Q. In the world of A's and B's, that's going to be the same thing as not A or B. And that's what I'm going to apply up into this thing. In this case, the role of A is going to be played by not P, and the role of B is going to be played by Q. So on the other side of this thing, what's going to happen is I'm going to have this not P is going to go where that A is. But you can see that there's still going to be a negation on the outside of that thing, which is okay. I know I can handle double negations easy enough, so that's not a huge point of issue. So I'm going to have the negation for that thing. And then on the inside of that is going to be a not P. It's going to be separated by an or, and now that Q is going to be where that B expression is taking shape. Whoops, I should actually write it as a Q then, not as a B. So that's the step. I'm going from this expression to this expression, and the reason why this works is it works because of this conditional statement number 2. It's this one right here. And if it helps, actually just rewrite this thing. I'm using the statement that says A implies B is the same thing as not A or B. And I always like to rewrite these things with A's and B's because a lot of times the problems or whatever you're working with might have P's and Q's already involved in it. And these things are usually involved with P's and Q's, and I just don't want to confuse all of those things. I want to think that this P is going to obviously be different than this P that's in this case. So just rewrite it with A's and B's, and that's totally fine. The P's and Q's are just arbitrary letters. You could write them as X's and Y's, A's and B's, I don't know, whatever random Greek letters you feel like coming up with as well. So in this case, my goal is to go from this expression down to this last part, and you can see that all that takes is just doing the double negation. So not P is just going to be a P or Q. And the idea for this is I'm using double negation. And that's it. That's all you got to do is you start with one side, you do a little bit of algebra, and then you end up at the other side. For those of you that have done trigonometry before, it is the exact same process as trying to show some of these trig identities. You start with one side of this expression, you try to work towards the other side, do a little bit of magic in the middle until you get to your final bit. Give me a little bit of justification on which process you're doing, so I'm not just thinking, oh, you made some kind of gigantic leak, but really convince yourself that you're going from here to here to here. It is, in a sense, a little proof. So you kind of bring about some of those proofwriting techniques that you've seen and kind of really letting the instructor or letting the kind of reader know what's going on in this case. Also letting me know what's going on in this case so that you can kind of prove yourself that you know all of these logical equivalencies. Okay, so let's do one that's a little bit more challenging in this case. We're going to be looking at the negation of the expression P implies Q, and I want to claim that this thing is the same thing as P and Q. So just as kind of you'd expect, what I want to do is I'm going to work with the more complicated side in these things, which sometimes seems a little bit against the grain, but it's easier to take a really complicated thing and make it simple than it is to take a simple thing and try to make it more complicated. So it may kind of take a little bit of convincing to kind of work through some of these, but it's easy to get rid of all these negations. It's sometimes hard to create negations as you go. So what's going to happen in this case is I'm going to start with the left-hand side. So it's going to be the negation of P implies the negation of Q. What I want to do to this thing is I want to apply some known logical equivalence. I'm going to go back and look at my giant toolbox in this case, which if you want to, this new expression is now part of my toolbox. I just proved it, so it's free to be used again. But what I want to do in this thing is I want to think about where am I trying to go. At the end of the day here, I'm going to have an expression that has an and at the end. I also have a negation outside of a giant conditional. So hopefully this third conditional statement is kind of jumping off the page as saying, use me, use me, use me. I want to play in this case. And that's what you're going to do here. I'm going to have a negation of this gigantic conditional. The negation of a conditional is going to leave that first expression all by itself. So I'm going to have a P. There's going to be an and because the negation of a conditional is going to bring about one of these ands. And then I'm going to apply that negation to that second object. In this case, the object already has a negation, so it's going to be a negation of Q. So here's where I'm using the conditional statement 3, or if you want to view this as the negation of A implies B, is the same thing as A and not B. And now you can see that I'm almost done. All I got to do is apply the double negation property, and I'm right to where I want to be. So I'm going to have a P, and the double negation of Q is just going to be Q, and here's where I'm using double negation.